Okay, okay. X minus 1, right, right. See, let's go to the different phase.
Oh, I wrote the other half in black in color, sir, just to make sure the.
Okay. It's the setting by you or by me?
So I just used another ink color, so it just
Okay.
got small.
Let's use it.
Do you want me to solve it again, sir?
Just wait, just wait. Okay. Right. The mistake here is you cancelled 1 minus 1 and 1 minus 1, right?
Yes, sir.
Let me tell you one thing. In this situation, okay. The problem is that, okay, okay. I understood. Just once clear the board. I noticed the mistake in our solution.
I knew it's this. I mean, it's near the 1 minus 1 part, sir.
Yeah,
But
I'm telling. Yeah.
yeah,
Clear everything.
so clear everything. Okay. Yes, sir.
Is it possible to clear it?
Oh, yes, sir. The other half, it was the question, so I didn't hear.
Okay, okay.
I don't think it's possible.
Oh, no
The other
problem.
half.
No problem. See, we are doing an interesting calculation. Let us take A is equal to B. Let us take A is equal to B, right?
Yes.
Multiplying both sides by A.
A square equals B A.
A square is equal to
A B B A.
of BA, right?
Yes.
Subtract B square on both sides.
A square minus B equals AB minus
AB minus,
B square.
AB minus, we are subtracting B square on both sides. We are subtracting B square on both sides. So that is A square minus B square. Right hand side is?
AB minus B square.
Very good, very good. You know, there is a formula for A square minus B square, that is A plus B times A minus B. A square minus B square is A plus B times A minus B. Got it?
Yes.
What about AB minus B square? What is common factor?
B square.
B is common factor, right? Then?
A minus B square.
Very good, very good. Dividing both sides by A minus B. A plus B times A minus B is equal to B into A minus B, dividing both sides by A minus B. What happens now?
Cancel A minus B.
Cancelling?
A minus B and
Yeah, do it.
A plus B
Do
equals B.
cancel A minus B on both sides.
So I think we did this once, sir. I don't think it's applicable towards the left side.
Yeah, just do it.
Okay.
We left with
A plus B equals B.
A plus B is equal to
B.
right. As we took A is equal to B, that means we can write B in the place of A.
B plus B equals B.
That's good. B plus B is equal to
B. 2B equals B.
divided both sides by B. BB cancel, BB cancel.
2 equals 1.
2 is equal to 1. Is 2 is equal to 1
No.
really?
No, sir.
It's a wrong conclusion. Absurd conclusion. It is absurd. Why we landed with an absurd conclusion? Because we did a mistake. But I'm sure I didn't do any mistake.
Yes, sir.
I myself didn't do any mistake. Even though we landed to 2 is equal to 1. Why? I said I myself didn't do any mistake.
Yes, sir.
But some mistake is there. Without mistake, we can't get 2 is equal to 1. I am saying I didn't do any mistake. I myself didn't do any mistake. The mistake is done by not me, by you only.
By me?
Yeah. You know where?
The cancellation part, sir?
Yeah, cancel. The only mistake is to cancel A minus B and A minus B. That's why I asked you to do that cancellation. Okay, right. Now, see. What is A is equal to B? Let us take A is equal to B. If A is equal to B, then what is A minus B? If A
B
is
minus
equal-
A.
of course.
Oh, 0, sir.
0, right? A minus B is equal to 0. How A minus B is equal to 0?
So B gets to the left hand side.
Yeah, of course. And subtract B on both sides. A minus B is equal to B minus B. A minus B is equal to 0.
Yes.
That means if you write 0 or not, A minus B is 0.
Yes, sir.
As you cancel the A minus B, you just cancel 0, 0.
I made the same mistake in the equation.
See, yeah, same mistake is done in that solution. See, that means whenever, suppose, if we cancel x, if we cancel x like this, that means we are saying the value of x by x is equal to 1.
Yes, sir.
What's the meaning of cancelling L by L? If we cancel L by L is equal to 1, that means
Yes, sir.
we are saying L by L is equal to 1.
Yes, sir.
By cancelling 0 by 0 is equal to 1, cancelling 0, 0, that means we are saying 0 by 0 is equal to 1.
Yes, sir.
Remember, we did the calculation to say that 0 by 0 is indeterminate form.
Indeterminate form. Yes, sir.
We cannot handle 0 by 0.
Yes, sir.
Whenever we get 0 by 0, we just stop there and get back. It is just like dead end to our calculations, to our process. 0 by 0 is nothing but dead end for our cancellation,
Yes, sir.
for calculation.
Yes, sir.
So what do we do whenever we get a dead end while going through a road?
Oh, we take a turn and we get back.
Yeah,
Right.
immediately get back. We can't hit that wall or something like that. That's why 0 by 0 is same as dead end. So we choose another process. We start from the beginning and choose another process. You did. Yeah, you need to clear it. Okay, no need to clear it. Just keep it there. At somewhere, what did you do? Factorize this, right?
Factorized it.
Limit x tends to 1. Today there is a fest in our college, not in our college, with my college students, college campus.
Oh.
Root X fest, that means farewell party, something like that.
Yes. Yes.
What is 2x square?
2x square plus 3x minus 2.
Yeah,
Minus.
tell the answer. X minus 1 times.
X minus 1 times 2x plus 3.
2x minus 3 or 2x plus 3?
Plus 3.
That's why we can't cancel 2x minus 3 and 2x plus 3. Okay.
Yes.
What did you do? Just you put x is equal to 1.
Yes, sir.
Then you will you saw 1 minus 1 here.
Yes, sir.
And then 1 minus 1 here. You cancelled because
yes,
1 minus 1 is same. But forgetting the fact that 1 minus 1 is equal to 0.
No, sir. 0 times something equals 0. So I thought the answer is undefined. I need to get rid of the 0, so I just cancelled it out.
Have you noticed the mistake in it?
Yes, sir.
We can, right. We can cancel. I'm telling one interesting fact in this discussion. We can cancel x minus 1 by x minus 1. You may ask me one question. We did in the same way. Let's come to this question first. We may cancel x minus 1, but we can't cancel 1 minus 1 by 1 minus 1.
Yes.
Cancelling 1 minus 1 by 1 minus 1 means cancelling 0, 0. Okay. That is nothing but hitting the dead end.
Yes.
Right. See, so we concluded that we understood that cancelling 1 minus 1 and 1 minus 1 is wrong.
Yes, sir.
You should not do like this. Then how should we do it? Right?
Yes, sir.
Just rationalize it. I told you some tips, some techniques. One technique is factorization.
Yes, sir.
Do you remember another one?
Rationalization and
Yes,
formula.
yes. Rationalization is also there.
Yes.
Here we can factor, we should factorize and rationalize also. What is the rational irrational term? Root x minus 1.
Yes, sir.
So multiplying numerator and denominator by
Root x plus 1
right, root x plus 1
by
by
root x plus 1.
now what is the numerator? Limit x tends to 1, 2x minus 3,
2x minus 3 times x
a
minus 1.
b to a plus b.
Yes, sir. X minus 1.
X minus 1 whole by x minus 1 times
X minus 1 times
2x plus 3.
2x plus 3 times root x
Yes.
plus 1.
Yeah, now
Oh, x plus 1 and x
what is cancel
minus,
now?
x minus 1 and x.
X minus 1, very good. X minus 1 cancel.
Yes.
Right? Now see. Limit x tends to 1, 2x minus 3 by
2x plus 3 times x root x plus 1.
now we can plug in x is equal to 1. Yeah,
Yes, sir. Then 2x
2 times 1,
1 2 minus 3 negative 1.
2 negative 3 whole by 2 times 1 positive 3
and
root
root
1 positive 1.
that equals negative 1
Whole by
by 10, sir.
2 plus 3 5. What is the root 1?
1, sir.
1 plus 1.
2, sir.
Negative 1 by
Negative 10.
so option.
Option 2, sir.
Okay.
Yes, sir.
Now you may ask, cancelling 1 minus 1 by 1 minus 1 is wrong. It's wrong. It's wrong. You can't do like this. Okay.
Yes, sir.
What did we do? What did we do in this calculation? We remember we cancelled x minus
X minus
1.
1 and x. Yes.
Now you may ask, what is substituted at the end?
Negative.
What is the substitution? That means plug in. What would we plug in the place of x?
1, sir.
1. To get this in this calculation, what did we do?
We plugged in once.
You plugged in 1. Okay. Plugging 1 means what happens now? What happens when we plug in 1 in this stage, at this stage?
Say it's going to be 0
By
0.
then how it becomes correct? Why in that calculation wrong? Cancelling 1 minus 1 by 1 minus 1 is wrong. By cancelling this type of by doing this type of cancellations, we got 2 is equal to 1.
Yes, sir.
At that stage, in that calculation, it is wrong.
Yes, sir.
Then how it is correct? We also plugged in x is equal to 1. We also plugged 1. X minus
Yes,
1 by x minus 1. We cancel x minus 1, x minus 1. Right?
Yes, sir.
Cancel x minus 1, x minus 1. But here it is correct. It gives correct answer.
Yes, sir.
Cancellation of x minus 1, x minus 1 gives correct answer in this calculation.
Yes, sir.
But doing the same cancellation in the previous cancellation went wrong.
Yes, sir.
Why? The reason is we must understand what is x tends to 1. What is x tends to 1? We need to
X is
understand.
reaching 1 and not 1.
Yes, that's good. X tends to 1 means x approaches. X approaches 1, but not x is equal to 1. It
Yes.
does not say x tends to 1 doesn't mean x is equal to 1. If it is x is equal to 1, we should write x is equal to 1 instead of x tends to 1. X tends to 1 is quite different from the term x is equal to 1.
Just,
So it is x tends to 1. X tends
yes.
to 1 means x is approaching 1.
Yes.
X is the value of x is nearly 1. It may be 1.1 or 1.01 or 1.0001, 1.0001 or 0.9 or 0.99, something like that.
Yes.
But we can't say the value of x.
Yes.
We can say the nature of x.
Yes, sir.
It is just near to 1. Okay.
Yes.
I'm telling you an interesting fact in this situation. There are no numbers between 1. There are no numbers between 1 and the value of x. The value of x is something like 1.00001, something like this.
Yes.
We can't say exactly, just something like this. Okay.
Yes.
The exact number is there should be no numbers between 1 and the value of x. The value of x is 1.0001. Can we insert any number between these two numbers? Is it possible to insert any number between these two numbers?
No.
See, for example, we can insert any number 1 and 1.1. Is there
0.5.
See,
all that.
there is a number between 1 and 1.1, that is 1.01.
Yes.
If we take 1.01, can we insert any number between 1 and 1.01?
No, sir.
Yeah, why no? 1.001 lies between 1 and 1.01.
Yes, sir.
Yeah, please tell the number like this. Okay, in which what is that number?
1.0000.
How many zeros?
4 and above, sir.
Okay, if you say that number is 1.00001, okay, you think that
Yes.
there is no number between this and this, right?
Yes,
I
sir.
put 5 zeros. That means 1.000001. Clearly, this number lies between 1 and this number.
There is.
Yeah, the number x is the nearest number to 1.
Yes.
Tell now, what is the nearest number to 1? Is it 1.00001? If you say this is the nearest number to 1, okay, we can say another number which is the more near to this than this number. That is putting 5 zeros.
Yes, sir.
We understand that there is a number very near, the nearest to 1, but we can't say that number. No one can say that number.
Yes, sir.
Yeah. Try another number. What's the nearest number to 1?
0.59.
0.59.
59.
Yeah. If you say 0.59, nearest to 1, that means more than 1, but nearest to 1.
1.2.
1.2. 1.1 is more nearer than 1.2.
Yes, sir.
So we can say the conclusion is that there is a number very nearer, the most nearer, the closest to 1. But we can't write that number, we can imagine only. I will conclude this. See, in mathematics, especially in calculus, there is a word, there is a letter saying epsilon. What is this? What is the name of this letter? Greek letter? Epsilon.
Epsilon.
It seems to be E, but not E.
Yes, sir.
It's called epsilon.
Epsilon.
It is epsilon. Okay.
Epsilon.
Epsilon. Right. This is used to, generally, this is used to denote the smallest positive number. The smallest positive real number. Please tell what is the smallest positive real number?
Epsilon, sir.
Tell one positive number, positive real number.
2, sir.
One is smaller number. One is smaller to 2.
Yes.
If you say 1, I would say 0.5. If you say
Yes.
0.5, I would say 0.4.
4.
If you say 0.4, I would say 0.3. What do you think of the smallest positive real number? Say one number.
0, sir.
Positive. 0 is not
No.
positive.
Yes, sir. 3. 1. 3.
3 is positive number. Okay. Is it the smallest positive?
No, sir.
Do you think that there are no numbers smaller than 3? There are no
Oh,
positive
then
real numbers?
it's 1, sir.
1. Yeah, then 0.3 smaller than 1, 0.5 is smaller than 1. Yeah, try one number.
Another number, sir.
Yeah. Try what is the smallest positive number?
Sir, it's just 1, no, sir. Smallest.
Real
number.
number. Real number means it need not be integer. Real number means it need not be integer. It can be
1 by 2.
1 by 2. Very good. That means 0.5.
Yes, sir.
Do you think that 0.5 is the smallest positive real number?
No, sir.
No. If you take 0.4, even 0.4 is not smallest real number. If you take 0.1, even the 0.1 is the not smallest real number. 0.01 is smaller than 0.1.
0.
If you think that 0. not, so on 100 times 0, 100 times zeros and 1. Even though, even this number is not the smallest.
Yes, sir.
We might put 101 zeros. The number which has 100 zeros after point and 1 is not the smallest, because
Yes.
there is another number which has 101 zeros.
Yes, sir.
So the smallest positive real number is 0. How many zeros? Even if we write 1 crore zeros, even if you write 1 after 1 crore zeros, it is also not the smallest positive real number.
Yes, sir.
Okay, why it is not the smallest positive real number?
There's another
Because
0.
we may write 2 crore zeros.
Yes, sir.
That's why I'm concluding that epsilon is okay.
Yes, sir.
A symbol to denote, epsilon is a symbol to denote the smallest positive real number. The smallest positive real number. but we cannot write its value. We
Yes.
cannot write its value. We cannot write its value. We can have an idea about epsilon.
Yes.
We have an idea about epsilon. We can't write its number. We know it. We understand it. But we can't write its number. If I try to write its number, okay, 0.000 so on. If I write 100 crore zeros after 100 crore zeros and end 1, you may say it is not the smallest partial real number. I can say another number which is smaller than this number. See, we are concluding this discussion. If I write epsilon is equal to 0.0000 so on 100 crore zeros. After that, I write 1. If I say it is the smallest partial real number, do you agree?
No.
I am saying there are 100 zeros, 100 crore zeros. Then what is our argument? What is our answer?
1,000 crore zeros.
Yeah, we may write 1,000 crore zeros after point.
Yes.
Between point and 1, it would be more smaller than that number.
Yes.
That's why mathematicians teasing one each other by saying your brain is smaller than your you have the brain whose capacity is epsilon. No mathematician accepts by saying his brain is as small as epsilon. I read a joke saying that when a mathematician, what is the unbearable comment to a mathematician? That is, your brain is as small as epsilon. Their language, we may not understand their language because they have higher intellectuality. So in that discussion, we can understand that epsilon is the smallest positive number. We can't write its value. Why I am having this discussion is we just doing sums in limits. Limit x tends to a f of x. We write this notation only, right? Limit x tends to f of x. We are writing just this notation and we are doing sums problems.
Yes.
But the definition is somewhat very complicated. And luckily, the definition of limit is not in the syllabus of 11th and 12th. It is in the definition, the actual definition. The actual definition is there in only graduation level, engineering or BSc level.
Yes.
The syllabus is just define, just writing this definition. In the definition, the concept of epsilon is used. Okay, after getting some experience in limits, definitely I'll make you to understand the actual definition, which is taught in graduation level. Okay,
Yes.
There, do remember, keep this point in your mind. That is epsilon. That is epsilon is used to define limit. Okay, it is nearly 1 week syllabus in degree level. The definition of limit.
Yes.
But in our level, in intermediate, that means +1, +2 level, we just use limit x tends to a f of x means the value of the value of f of x when x approaches a. Then x approaches a. The value of f of x when x approaches a. Okay, why I am saying these points here is in one case, cancelling 1 minus 1 is wrong. At the same time, here the cancellation of x minus 1 is correct. Here this cancellation is correct. Here this cancellation is wrong. You may think that if it is wrong, why it is correct? Okay, the reason is we didn't cancel 1 minus 1 here. There we cancel 1 minus 1. There we cancel 1 minus 1. It went wrong.
Yes, sir.
But we didn't cancel 1 minus 1 here. We didn't cancel 1 minus 1 here.
Yes, sir.
We cancel the number which is 0.00000 something like that
Yes, sir.
by 0.0000 something like that. We cancel that number.
Yes, sir.
That number, because the difference between x and 1, the difference between x and 1 is not 0 here,
Yes, sir.
not 0 here. The difference is epsilon.
Yes,
The value of x minus 1 is epsilon. The value of x minus 1, the value of x minus 1 is epsilon,
yes,
but not 0. Epsilon is not 0, but nearest to 0, but not 0.
yes, sir.
Please tell, here we cancel x 1 minus 1. We cancel 1 minus 1. That means 0, 0 cancelled here.
Yes,
But here the number cancelled is not 0. Which number is cancelled in this calculation?
epsilon.
Epsilon is cancelled. Epsilon is cancelled. The value of epsilon is not 0.
Not.
It is the smallest positive real number. Smallest positive real. Cancelling 0, 0 is wrong. Cancelling 0, 0 is wrong.
Yes.
Yeah. Cancelling 0, 0 is wrong. Cancelling 0, 0 is wrong. But cancelling 0 points some zeros 1 and 0 points some zeros 1 is correct. Okay. Let's go for the next sum. Is it possible to clear them? Not possible.
No, sir.
No problem. See, subject is ocean, mathematics is ocean. We learn as many things as possible in our lifetime. Wisdom is divine, you know.
Yes, sir.
I'm telling one thing. What's the roadmap? What's the roadmap to find the limit of a function? Do you remember? First, step 1. See, the question is, limit extends to a f of x by g of x. It's the question, right?
Yes, sir.
To find its value, what's the roadmap? Step 1. Put x is equal to a. If we get not equal to 0 by 0, not equal to 0 by 0, go ahead. Go ahead. If you don't get, okay. Step 2. Get back. Clear?
Yes, sir.
Step 2. If it is 0 by 0, okay,
Yes.
Choose suitable procedure. First one, formula. Check, is there any formula for it? I told few formulae in the last class, okay?
Yes.
Second one,
Rationalization.
factorization, very good. Factorization,
Precision.
yeah. Take the screenshot of these notes.
Yes.
Third one, rationalization.
Precision.
Fourth one, L hospital rule. It is new one. How do you read it? L'Hopital?
Hospital room.
Yeah,
I don't know.
yeah. In foreign countries, there are some names which are written like this. D. Alembert. He is also a mathematician. I see there is a hyphen. D. Alembert.
Oh, yes. So there are a lot of hyphens and
Yeah, in foreign names. And also L hospital. Some areas it is read as, especially in Telugu states, it is read as L hospital. But if I go through next and ask for the pronunciation, it says L'Hopital. L'Hopital. Okay, anyhow, it is a special rule. It is a special rule used in limits. And the condition is the using L hospital rule in board exams is prohibited in Telugu states. That means Telugu boards. But in other states, it is used L hospital. L hospital rule can be used in board exams in CBSE. But in state syllabus, Andhra and Telangana state syllabus, it is not correct to use L hospital rule. Because there is controversy in L hospital rule. I will tell later after getting more experience. You see, don't feel it is difficult. The concept, don't feel, yeah. The trick is that the method is, the way we think is, whenever we get a hard topics, we should not feel it as difficult. We should feel it as it has much depth. This concept, yeah, I agree that the concept of calculus, the concept of limits has much depth. It has much depth. Okay. So there are a lot of things. To know in this concept. Okay.
yes.
So this is wrote down. What is the first step? What is step one?
Put x equals a.
Right. Then, if you don't get,
If we don't get 0 by 0,
okay.
then
If you don't get 0 by 0,
we can go ahead.
very good. Yeah, yeah.
But if we get,
Let us teach you these steps step by step slowly. For example, if we take limit x tends to 2 x square minus 5x plus 6 whole by x plus 2. Yeah. Take step 1.
x equals a, that's x equals 2, sir.
X is equal to, yeah. What happens if you put x is equal to
2 square 4 minus.
Just wait. It is x minus 2. It is x tends to 1. Yeah. Wait.
1 minus 5 plus 6.
Yeah, 1 minus 5 plus 6 whole by
negative 1s.
negative 1, right? What is the numerator?
1 minus 1. 0 by negative 1s.
Yeah. No, not 0. 0 is moving around our mind.
Isn't it?
Why 0?
6 and negative 5 is positive 1 and 1. Oh, 2, sir.
2. Because we have a lot of we had lot of discussion regarding 0.
No.
Yeah, we had 0 centric discussion. Okay, that's why you are
Yeah.
still thinking about 0. 2 by -1, which is equal to
Negative
-2.
2, sir.
Right. So is it did we get 0 by 0 form or not?
No, sir.
No. That's why we can go ahead.
Yes, sir.
So its answer is 1 minus 5 plus 6 whole by 1 minus 2
Yes, sir.
is equal to by -1. It is equal to -2. It is correct answer.
Yes, sir.
It is correct answer. Okay. Another
Yes.
question. There are some questions in limits. Simple. Directly we can put x is equal to a. Please do this question on the screen. The question is limit x tends to 2. X square plus 4 by x plus 2. Do it.
Equals 4 plus 4 by 2 plus 2. That's 8 over 4. That's 2, sir. So is the answer 2?
Answer 2. Very good. I'm giving another question. Limit x tends to 2. X square plus 5x plus 6 by x plus 2. X plus 3. Do it.
4 plus 10 plus 6 by 5. That's 20 by 5. That's 4, sir.
Very good. Very good. That's correct. But now my question is,
1 second.
yeah, I can hear. But now my question is, limit x tends to 2. X square minus 5x plus 6 by x minus 2. Right? Yeah. What happens if we put x is equal to
4 minus
4 minus
10 plus 6 by 0.
Yeah, that is
0 by
10 minus
0.
10 by 2 minus 2. 0 by 0. Okay. So what is step 2? What is its conclusion?
We have to use the
How to get back first immediately?
yes, sir.
Yeah.
Alternative
Alternatives. What are alternatives? Formula or factorization
form.
or rationalization, right?
Yes, sir.
Now let us factorize.
Yes, sir.
Factorize in numerator.
X square minus 3x minus 2x plus 6.
X square minus 3x minus 2x plus 6. Take x common.
X minus 3 minus 2 comma x minus 3. X minus 3 times x plus 3.
So the numerator is x minus 3 times x minus
3 times x minus 2 by x minus 2. X minus 2, x minus 2 gets cancelled. X minus
why we should why we cancel here? Because
yes,
by cancelling x minus 2, we are not cancelling 0, 0.
the 0.
Even though x tends to 2, x approaches
Yes,
2. X approaches 2 means x is not equal to 2. The value of x is something like 2.0000001 like that.
yes, sir.
That means we didn't cancel 0, 0. We cancelled epsilon, epsilon.
Yes, sir.
Epsilon, epsilon.
Then
Yeah, epsilon, epsilon can be cancelled, but 0, 0 cannot be cancelled.
yes,
Epsilon is the nearest number to 0. Okay.
yes.
Now put x equal to
2 minus 3 negative 1, sir.
is equal to -1. So its answer is -1.
Negative 1.
Okay. Try the following sums. Limit x tends to 3. x square minus 7x plus 12 by x minus 3. It extends to 2 x square minus 9x plus 14 by x minus 2. Limit extends to 5 x square minus 25 by x minus 5. Limit extends to 3 x cube minus 27 by x minus 3. Limit extends to 2 x square minus 4 by x minus 2. Okay.
Yes.
Try these five sums. Try these five sums. We will be having very interesting discussions on this topic tomorrow. Meanwhile, try these five sums.
Yes, sir. I took the screenshot.
Yeah. And same time. Actually, same time. I am not connecting the class comment class at 5:30 because today and tomorrow may not possible. They may not attend. They are busy in practicing cultural programs. Okay. If they wish, we may have class tomorrow because
Yes.
all the students are not participating.
Yes.
Yeah.
Yes.
We'll have class at 4:30. For that class, try these five sums.
Yes, sir.
Okay. Bye. Good day,
Thank you.
Anika.
Thank-
Okay.
Have a good day.